to talk. Hello my dear friends, welcome to IMS Academy. Hello my dear friends, welcome to IMS Academy. I am Sourav and I am welcoming you to this challenging series of heat transfer. My dear friends, yesterday we had the challenging series for industrial engineering and I am sure that you have enjoyed it. So my dear friends, today we are having this HT and very quickly I will be solving 4 to 5 questions, and if that is done, so that you get a taste of questions just 1 day or 2 days before the examination, right? On 3rd you will be having the examination, and again the motto is that you keep on revising. Your purpose should be only to revise. Good morning, Thiru. Fine. You can consider joining our Telegram group where you will be getting regular quizzes, job updates at the earliest, and I am sure you do not want to miss any notifications, right? My dear friends, without wasting any time, let us quickly come to the purpose, and the purpose is to get revise of the questions. So please read it once. What is the question saying? I will move out of the screen. So the question says a hot surface at 100 degrees centigrade is to be cooled by attaching 3 centimeter long 0.25 centimeter dia aluminium pin fins whose K is given as 237 with a center to center distance of 0.6 centimeter. The temperature of the surrounding medium is 30 degrees centigrade and the heat transfer coefficient on the surfaces is 35 watt per meter square degree centigrade. Determine the rate of heat transfer from the surface. This section of the plate, also find the fin effectiveness. So all in all, this is a very good question, and earlier also I have taken such kind of question, but I have just added some extra information to be asked in the question, right? Here I have asked fin effectiveness. Now my dear friends, you need to understand that on this plate fins are there. Not every area is being covered by fins. There are some faces where fin is not present also. So what he is asking? He is asking determine the rate of heat transfer from the entire area. So what we will do? First we will find what is the heat transfer from the fin, then we have to find what is the heat transfer from the unfinned surfaces, and then we will add both the heat transfer areas. That is the concept. Okay. So the first job is we have to calculate what is M for a fin. So H is 35, perimeter of the cross section is pi into D, and I will put all the units I will be keeping in SI. So it is 0.25 into 10 power minus 2 K is 237, and what is AC? Pi by 4 into D square. So when you calculate the value of M, you will be getting as 15.37 per meter. Now in any fin question, this is the first thing that we will find out. This is the first thing that we will find out. Now my dear friends, you need to find out that how many fins are there, in, on the entire 1 by 1 meter square area. That is a very challenging task. So what I will suggest is, for example, this is the let's say this is the one segment of the area that I am showing, and he is saying that fin to fin distance is how much? 0.6 centimeter. So this distance is 0.6 centimeter. This distance is 0.6 centimeter. This distance is 0.6 centimeter. This distance, right? This distance is 0.6 centimeter. So effectively in 0.6 by 0.6 centimeter square, one fin is present. Right? One fin is present. So altogether what is the total area? The total area is 1 meter square. 1 meter square. So what is the total number of fins? What is the total number of fins? That is equal to the total area 1 divided by 1 fin is present in 0.006 into 0.006. That is a meter square and meter square. So this will come out to be this much number of fins. And now for heat transfer, we have to find what is the total surface area from where heat is transferring out. So total surface area. So for one fin, heat transfer is taking place from the curved surface and from the end surface. So curved surface is nothing but pi dt or pi dl, and curved surface you know. So pi d into L, okay. Pi d into L plus the end area is pi by 4 d square, and this is for one fin, but for how many total fins are there? This much. Remember, whatever we will put, that will be in SI only. So 27777 pi into what is diameter? Dia is 0.25 centimeter. 0.0025. What is L? 0.3 centimeter. So 0.03 plus what is dia? So what this area is coming out to be? Total surface area. This area is coming out to be how much? This area is coming out to 6.68 meter square. 6.68 meter square. 6.68 meter square. Now my dear friends, this is the finned. This is the finned area. What about unfinned area? what about unfinned area? Because fins are not occupying everywhere. So total area is 1 meter square minus for one fin it is pi by 4 into d square. D is 0.0025. But how many fins are there? 27,777. So this is the unfinned area, and this is coming out to be 0.86 meter square. Unfinned area is coming out to be this. So you have finned area, you have unfinned area. You have finned area, you have unfinned area. Now, how to find the heat transfer? How to find the heat transfer? So a simplified way of finding heat transfer is if I find the efficiency of the fin first. If I find the efficiency of the fin by using this formula tan H ml by ml, if I find this efficiency, then I can very easily find the heat transfer. So what is M? M is 15.37. So efficiency will come out to be and finally the heat transfer from the finned, is efficiency into Q of max heat, So efficiency is 0.935, and what is max heat? Max heat is when your entire surface is at the temperature of the fin. So that is H A TB minus T infinite. H A TB minus T infinite. So this is 0.3595. What is H? H is 35. What is area of the fin? Area of the fin is just now we have found out 6.68. 6.68. What is base temperature? 100. What is ambient? 30. So if you solve this, you will be getting 15,300 watt. If you solve this, you will be getting this one. Now the problem is not done. This is Q finned. So what will be Q unfinned? Because not everywhere fin is present. So Q unfinned will be H area of unfinned TB minus T infinite. So H is 35. Area of unfinned is how much? 0.86. And TB is 100 minus 30. So if you solve this, you will be getting 2107 watt. And now the total heat transfer area. Now the total heat transfer is nothing but Q of finned plus Q from unfinned. So Q from FIND we got as 15300 and Q from unFIND we got as 2107, and if you add them you will be getting 1.74 into 10 to the power 4 watt or 17.4 kilowatt. This is the first part of the problem where he is asking the heat transfer. And now he is also asking effectiveness. So effectiveness of the fin is Q when fin is there and Q when no fin is present. So when no fin is present, it is H entire area del T. Entire area is 1 meter square and del T is 100 minus 30. So Q with no fin is 2450 watt, right? So then finally, what is the effectiveness? Effectiveness is Q when fin is present, so it is 17,400 by Q when no fin is present, 2450. And when you solve this, you will be getting your answer as 7.10. So this completes my entire question. This completes the entire question. So just see the concept once. So what was the question? That this is the fin given. Generally, whenever you have studied fins, you have considered that entire area is being occupied by fin. But it might not be the case, na? It might not be the case. It might not be the case. It might not be the case. So first we have to find out where from area we have to separate out two things, from where heat transfer taking place, fins and the unfinned areas, and from there I have calculated separately the heat transfer and then I have added. Are you getting or not? Are you getting this concept? So first we have completed what is the rate of heat transfer and then we have found out what is the fin effectiveness. So I hope the concept is clear, and I strongly feel that if, please see this question from fin, this I think that it has a very high potential of coming. Obviously if it comes, it will be a very tough question from the gate perspective, but it might come, okay. And if you are solving this question, if you have understood this question, then no need to do any other question from fin, this much I can say. Okay. Please read the next question, another good question from HT. Please read. Please read the question. Okay, the question says that combustion gases passing through a 3 centimeter internal dia circular tube are used to vaporize, just a minute, are used to vaporize wastewater at atmospheric pressure. Hot gases enter the tube at this and this at a mean velocity of this and leave at this. If the average heat transfer coefficient is 120 watt per meter square degree centigrade, inner surface temperature of the tube is this. Determine the tube length and B the rate of evaporation of water. Another very good question from your convection. And the properties of air at the average temperature of are given. All this extra information has been given to you. All this extra information has been given. Actually, this is a combination of heat exchanger plus some concept of convection. It is a mixed bag question where some concept of convection, some concept of heat exchanger, both will be taken into account. Both will be taken into account. Okay. So just remember, my dear friends, that whenever he is asking about the tube length, your ultimate objective is that from what area heat transfer is taking place. If you somehow calculate AS, that from which area heat transfer is taking place, then we can very easily find how I can very easily write pi dl, where L is the length of the cube. Length of tube. Diameter you know already, no need to find. Okay. And how to find AS? Q is equal to HA delta T. So Q we have to find out. A we know. Now what is delta T? Delta T is the difference between, at any section, the difference between hot gases and the wastewater temperature. So for example, if I want to find out what is the difference, so wastewater is maintained at a particular temperature of 110, but my dear friends, at the entry the hot gases is at a temperature of 250 degrees centigrade and at the exit it is at 150. So can I say that it is changing across the length? So a constant temperature difference you will not find at any particular length. It is always changing. And whenever temperatures are changing, we have to find the average. Without average, we cannot proceed. And that average we will get by how? LMTD. Because we have the 4 temperatures. We have the 4 temperature. It is the case of boiling of water. We have the 4 temperatures: inlet, outlet, and wall temperature, where fluid temperature 110. And whether you consider LMT, whether you consider counter flow or whether you consider parallel, the formula is same only, right? So LMTD delta Tm we will very easily find out. H is already given. And how Q will come? Q will come from the information of hot gases. How? All the information of hot gases is given, and suppose the fluid is changing, is taking some heat and it is changing from one temperature to the other temperature. So I can very easily write M Cp delta T. Obviously I have to find M. Cp is given, very good, Cp is given. Cp is given, and Delta T I can vary, delta T is also given, delta T is also given. So I think the roadmap is clear. The roadmap is clear, and now we can very easily. Please check the question again. Please check the question. Is the roadmap clear? Is the roadmap clear? Okay. Now you will be thinking that, sir, how to calculate mass? How to calculate mass? ठीक. So mass is rho A V, rho of air so should I take it 1 point no, we cannot take 1, we have to calculate. Now air is an ideal gas, okay, air is an ideal gas, air is an ideal gas. So P is equal to rho RT. So rho I can find out by P by RT, and P is given as 115 kilopascal. What is R? 0.287. And T at the inlet is 250, but you have to convert in Kelvin. Okay. So when you cancel out all these things, you will get the answer as 0.766 kg per meter cube. So once rho is found out, rho I have found out. So what is m dot? Rho is area, is the cross section area. What is dia? 3 centimeter. And what is velocity? What is velocity? Velocity is 5 meter per second. Velocity is 5 meter per second. Velocity is 5 meter per second. So everything I have put it in SI in unit only. What is m dot? M dot is coming out to be 0.00 kg per second. So what is m dot? M dot we have found out. So m dot we have found out. Cp is given, delta T we know. So can we find Q? So therefore Q is equal to m dot is Cp is given as 1023. And what is delta T? 250 minus 150. 100 I can write. So this answer kg per second and watt. So answer should come in watt. When you solve this, you will be getting 2 watt. So Q has come out to be 276.9 watt. Now, hot air inlet temperature is 250, exit temperature is 150, and constantly the boiling water is maintained at 110. So delta T inlet will be, considering parallel flow, this one, outlet will be this one. So what is LMTD? So LMTD is so what is that average temperature? 79.82. So LMTD is also known. Now Q is equal to HA delta Tm. So Q we have found out 276.9. What is H? H is 120. Area we have to find out, and delta Tm is 79.82. So from here, what is AS? And this AS only should be equal to pi dl, so that we can found out L. So what is dia? 0.03. And what is L? So from here, L is coming out to be 30.7 centimeter. L is coming out to be this. But the question is not over yet. He is asking what is the rate of evaporation of water, the rate at which evaporation is taking place. The rate at which evaporation is taking place, and he has given that the heat of vaporization of water at 1 atm is this. Right, 2257 kilojoule per kg. Now M into what is what? 276.9 joule per second. Joule per second. And what is 2257? 2257. So H is 2257 kilojoule per kg. Rate of heat is 276.9 joule per second. So question is, what is m dot? What is m dot? Obviously it will be in kg per second. So my dear friends, sometimes we are confused, like what should be the formula, that how to find m dot. Now I'll simply tell you that try to take help of the units. Try to take help of the units. How unit is being satisfied? How unit is being satisfied? For example, if I divide q by h, if I divide q by h, so it will be joule per second divided by kilojoule per kg. So the unit is coming out to be kg per second. So very easily I can get it from here only, just by writing the units I will be getting. So joule per second, or in terms of kilojoule it will be 0.2769 kilojoule per second, that is kilowatt, and that will be obviously kilojoule mein to 2257, and whatever is the answer, that will be your m dot. Like it is coming out to be, yes, it will be a very small number when you have written in terms of kg per second, but I can also convert in terms of hour also by multiplying with 3600. So in terms of hour it will be 0.442 kg per hour. So this is the end of another very amazing question on the mixed bag concept of convection and LMTD, convection and LMTD, convection and LMTD. Please go through it. Please go through it. Okay. So if this is clear, we can go to the next question. Please read. Please read. Please read the question. Two very large parallel plates are maintained at uniform temperature of 1000 Kelvin and 800 Kelvin and have emissivities of E1, that is epsilon 1 only, and epsilon 2 as 0.2. It is desired to reduce the net rate of radiation heat transfer between the two plates to 1/5 by placing thin aluminium sheets with an emissivity of 0.15 on both sides between the plate. Determine the number of sheets that need to be inserted. My dear friends, radiation shield is so important topic, such an important topic, and from there I have taken one of the good questions, one of the best questions I have taken. So make sure you go through the question at least you go through the question and you get to know the solution. At least the least you can do is this thing. So what is the roadmap over here? First we have to find heat when no shield is there. No shield is there. And then we have to find out with N shields, formula with N shields. Formula with N shields. This is it. This is it. Right. And from there only we will get the answer. So let us do it. So see, this is the question. T1 and T2 are given with emissivity. So what is the formula? Question, what the question is saying? The number of shields. So Q is sigma now this is the formula for two large plates at a distance, infinitely large plate, by 1 by what is T1, what is T2, so what is the heat transfer? What is the heat transfer? 3720. Mind it, this formula is for flux. Flux matlab, flux is the meaning of flux divided per unit area. Okay. And now what is the Q with N shields? Q with N shields. So it is sigma and from here N shields I have inserted. I have inserted N shields 1 by epsilon 3(1) plus 1 by epsilon 3(2) minus 1. So when you will substitute all the values, N shields. Now this is given to be the emissivity of the shield 0.15. 0.15. Okay. And he has given that the heat transfer is to be reduced by 1/5. 1/5 of the original. So what is the original? 3720. 3720 is the original. And from here we have to find the value of N. From here we have to find the value of N. So if you solve this, I am leaving the calculation to you. You will approximately get the value of N to be you will get the value of N to be 3. Approximately. I am leaving the calculation to you. Very easily you can do the calculation. Approximately you will get the value of N to be 3 shields. Right? So another good question on radiation. Right? This question What is the question saying? The question is saying determine the view factor from the conical surface to a hole. This question I have also taken in my previous series. So what I want is that I am not discussing it right now. I want you guys to try this on your own, and in case you don't get the solution, you can refer it to the previous series, right? So I am leaving this question for you to try. I am leaving this question for you to try. And now let me take the final question, that is this question. Let me take the final question of the day. Please read the question once. Please read the question once. Please read the question once. So the question says that a 6 meter long section of a 8 centimeter dia horizontal hot water pipe shown passes through a large room whose temperature is 20 degrees centigrade. If the outer surface temperature of the pipe is 70, determine the rate of heat loss from the pipe by natural convection, and the properties at the film temperature has been given. So this is a question of okay, so Atul is saying what is the answer of the previous question? The answer of the previous question is this. Okay. Okay. Tell. Have you got this answer? Okay. Can we move then to the next question? Okay. Welcome. So how to solve this question? He is saying determine the rate of heat loss by natural convection. By natural convection, we have to determine the rate of heat loss. Now one thing you are noticing over here, that generally in the question you will not find any relation of Nusselt number with Rayleigh number. You have some already memorized data which is applicable only for for a specific set of values, 2-3 relationships you have memorized, but here he has specifically given the relation between Nusselt number and Rayleigh number, right? So one thing is there, no need to panic. We will follow the same set of rules which we follow for the free convection. What is the set? The set is, first you have to know what is characteristic length. From there you will find Grashoff's number. Then you will multiply with Prandtl number to get Rayleigh number. Yes or no? And then from there you have to find what is Nusselt number. Then H value you will find out, and finally you will find out the rate of heat transfer. Then you will find out the rate of heat transfer. Okay, so first LC, then Rayleigh number. When you substitute this Rayleigh number over here, you will get Nusselt number. Once you get Nusselt number, then you can find out the value of H. Once H is known, then you can find out the value of heat transfer. Okay, Atul, we have solved it already. Please try. If you are not able to try, then I'll give the solution. No, don't worry. Already that question has been solved earlier. Okay, so you can refer the previous video for the solution. Okay, focus on this question as of now. Now, since this is an convection is taking place. What is saying? A 6 meter long horizontal hot water pipe passes through a large room whose temperature is this. So from the external surface, convection is taking place. So here the characteristic length becomes the diameter. And once your characteristic length is found out, that is, it is known that it is equal to the dia of the pipe, and then you can find Grashoff's number. What is Grashoff's number? Let me solve it. So Rayleigh number is Grashoff's number into Prandtl number. Okay. And what is Grashoff's number? G beta delta T LC cube by nu square. This is Grashoff's into Prandtl number. Now I'll put the values. Delta T, you know, LC cube is D, and what is beta? Beta is 1 by T mean, but it should be in Kelvin. So one by one I am putting the values. It is 9.81. Beta is 1 by the mean temperature. What is the mean temperature? 45 degrees centigrade, but it is in centigrade. In Kelvin it is plus 273. So 1 by 318. What is delta T? 70 minus 20. LC cube is the dia. Dia is 8 centimeter. So 0.08 cube. And what is nu square? Nu is also given. Nu is given to be so when you solve this, you will get the wait, one thing is missing. Prandtl number is also given, and we have to multiply. So it is and once you do the calculation, you will get the Rayleigh number to be 1.869 into 10 to the power 6. This is your Rayleigh number. What to do with the Rayleigh number? You will substitute over here. Prandtl number is also given. You will substitute over here, and finally you will get the Nusselt number. Finally you will get the Nusselt number. Okay. So I am substituting. Now this relation has already been given. I am only doing the work of substitution. Don't think, or no need to memorize this relationship. they will give you, if this is the case, they will give you so what I have done, I have only substituted the Rayleigh number in the given relationship, and when you solve this, you will get to be 17.40. Once Nusselt is known, you know that it is nothing but hd by k. From here find h. From here find h. So Nusselt number is 17.40. K and d value. So k value is given, d value you know. So this is the k value 0.02699. 0.02699 k value, and d value you also know 0.08. So h value you will get to be and once the h value is known, you know that in entire convection the heat transfer formula is HA delta T. So H value you know, we have calculated. Area we have to find out pi dl, because from pi dl external surface only heat transfer is taking place. So pi into, and what is the length? 6 meter. Pi dl, and delta t is 70 minus 20. 70 minus 20. So when you solve this, you will get your answer to be 443 watt. You will get your answer to be 443 watt. 443 watt. Right? So clear, the question is clear. See, in any convection question, finally we have to use the relation HA delta T only. So H we have to find. How did we found H? From Nusselt number. Nusselt number relationship was given with Rayleigh number. So what I did, I first calculated the Rayleigh number, which is Grashof into Prandtl. See, this is all about algorithm. If the algorithm is fixed in your mind, you will be very easily able to calculate the whatever question is saying. But you need to know the given set of algorithms. Once Rayleigh number was found out, I calculated Nusselt number. From Nusselt number H say HA delta T. Right? So here we are going to stop today, and yesterday we conducted Industrial Engineering Challenging Series. Today was HT, and now I wish you all the best for your examinations. So here I'll end the session. For any doubt you can ask in the comment section. If you are finding it useful, please do like and subscribe. And finally, you can join our Telegram channel, where you will be getting the job updates at the earliest, along with some quizzes, daily quizzes, right? So I'll be keeping it here. Thank you very much. God bless.